tonight we're trying to show that the sum of the first p minus 1 cubes is divisible by p squared. That's what this congruent statement says. Okay, so let's work with a concrete example. Let's try 5. Now, it's very easy to verify that 2, the prime 2, doesn't work here, and 3 works. You can verify that. 5 is a little less trivial, so let's take a look at 5. So for p equals 5, we're actually going to be summing up 1 cubed plus 2 cubed. Now notice that p minus 1 is 4 here, so we're going to run all the way out to 4 cubed. Okay, folks, this reads 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. Now, this is what? 64 plus 27 is 91 plus 8 is 99, so we get 100 here. And you'll note that that certainly is divisible by p squared. P squared is 25, right? P squared is equal to 25, which is what this is really saying right here. Another way, this modular arithmetic way of stating this. So this is equal to 4 times 25. Okay. So that special case works. Now let's take a look at the more general case. And not surprisingly, this result from calculus that gets used when students are trying to do the limit definition of the Riemann integral, the sum of the first n cubes, not surprisingly gets used right here. So it's very clear what to do right here. You just replace n. Since this holds for all n, you can replace it with another integer, namely a prime minus 1. And so that's exactly what we do right here. We put the p minus 1 here. If we put p minus 1 here, we end up with p squared, which is crucial. Now, we're just about done here. One thing to note right here is that p minus 1 is odd. P is an odd prime. Remember we said 3, so all the primes are odd other than 2. So this is an odd number right here. So in other words, p minus 1, let me write this down. P minus 1 squared has to be a multiple of 4, right? Has to equal to 4k, let's say. Okay, we haven't used k yet, have we? Yeah. So p minus 1 has to be equal to 4 because it's by an odd number. Minus 1 is an even number. When you square an even number, at least a multiple of 4 is going to pop out, right? Okay, so that means that this part right here is going to resolve to an integer. In other words, p minus 1 quantity squared divided by 4 is going to be a natural number, okay? Since this 4 will cancel with this 4, right? So I'm going to write down it's a member of the natural numbers, okay? In other words, it's a real, it's just an integer, a positive integer, all right? So you see we're pretty good right here because if this part is an integer, all right, then we have p squared right here. This is clearly congruent to 0. Mod p, right? Mod p squared. That's literally the definition. That's another way of writing it, right? So we'll write congruent to 0 mod p squared. That completes the proofs, folks. So that's the end of that. Let me write a QED here. And enjoy the rest of your day.